ELI5. Why are there mountains that are 10 or 15 miles high on Earth? Plate tectonics. Earth's crust sits on a molten core, Mars doesn't. Olympus Mons is a volcano. Lava spewed up and up for a very long time. But on Earth, the plates were moving, so instead you get a string of volcanoes. Like poking your finger up through a surface that was always moving. Likewise with mountains, when two plates collide, one is forced downwards into the mantle and the other buckles on top, forming mountains but always moving. Did you just finish the Watchmen graphic novel? I would imagine erosion plays a role. I know the Rockies are actually shrinking now because the plates stopped moving into each other. I would also dare to speculate that since Earth is very warm under the crust, that it is lubed up a bit more by the magma and plates are more free to slip back away after a collision with each other. I'm not a geologist though, so this is all wild speculation on my part. Lol. Hey, I read something about this recently. Apparently it's because the higher a mountain grows up into the atmosphere, the more erosion takes place because the water on the peak freezes, expands, and fractures the rocks, leading to erosion. Mountains in warmer areas can get higher than those in cold climates. But these are all incorrect, or misunderstandings. The reason they aren't tens of km high is because of erosion. That can be influenced by gravity, but it's primarily freeze-thaw, rain, earthquakes, and the rock not having the shear strength for chunks of rock to fall off. The taller a mountain gets, your angles increase and thus it's more susceptible to being eroded. Don't know, but I found this your starter answer. Mars lacks mobile tectonic plates. The extraordinary size of Olympus Mons is likely because Mars lacks mobile tectonic plates. Unlike on Earth, the crust of Mars remains fixed over a stationary hotspot, and a volcano can continue to discharge lava until it reaches an enormous height. There are some good detailed answers here, but to keep it simple, it comes down to a few main things: stronger gravity, plate tectonics, and erosion. Stronger gravity pulls mountains down harder. Active plate tectonics can destroy mountains. Rain, wind, and weather in general wears mountains down over time. Similar to jelly, you can fill a jelly mold that's huge and deep, and tip it out. But it will collapse under its own weight and spread out to a certain level. You could add more jelly on top, but it will just do the same thing and push down and spread outwards. Same with mountains, only less jelly, more rock. The gravity play has role, but geophysical evidence indicates that the full height of Mauna Loa above its base is an astounding 19 kilometers, more than twice the height of Mount Everest above sea level. Mauna Loa is a basaltic volcano over in hot spot, similar situation that month Olympus on Mars. Olympus Mons is kind of a weird one. Mars didn't have shifting tectonic plates, so the hotspot just sat there, making Olympus Mons bigger. On Earth, plates shift, moving active volcanoes off of the hotspots. Hawaii is an example of this. A mountain that starts at sea level will appear to be relatively short compared to a mountain that starts at the surface of the crust. Olympus Mons would appear much shorter if surrounded by a Martian ocean. If you took all the water away, it would make a significant difference. There isn't any surface water on Mars. The Pacific is 6.7 miles plus deep, so add that to Everest, it's pretty high. Weather, basically. Various cycles bring water and chemicals into the sky that then falls down on mountains, dissolving them as silt brought by rivers down eventually to ocean floors. Rain. Earth has an atmosphere and active climate system. Rain, ice, and snow are really good at erosion and knocking mountains down in the blink of an eye. Geological speaking, isn't Everest growing? But you also have to consider the weather effects. Wind is a big cause of rock erosion, with water of course. High up the air is more moist and it's windy. I have heard it's due to a lack of plate tectonics on Mars. Volcanoes just keep endlessly building up. There was a recent short on the physics girl about it. The Earth is such a perfect circle that if you shrunk it down to the size of a billiards ball, it would be smoother than any billiards ball that we make. Mauna Kea is about a mile taller than Everest but starts on sea floor. Just fun fact. Some pretty tall mountains depending on where you consider start. I may be dumb, but I think Mount Everest's height is above sea level, and with Mars not having a sea, that might be skewing the data a little. Am I wrong? Do we know the size of the planet at what point gravity would squeeze it to a perfect sphere? Assuming it wasn't spinning enough to make it oblong. Olympus Mons is like 13.6 miles, basically 2x of Everest, but yeah! Pretty cool that one mountain volcano is the tallest in the solar system though. A good way to imagine this is to go to the beach and start building a mountain with the sand. There's a point where it will start crumbling. Earth heavy, pressed down. Rocks not stacked too high. Shell weak, out limit. Everest, tall but not biggest. Mars mountain huge. Earth can't. Gravity limits how tall a mountain can be before it's too tall and heavy to support itself. Mars has a much lower gravity,